Okay, so hello everyone, welcome. Can you hear me?
Yes, sir.
Okay. Just we're waiting 1 minute for joining all of the other person. I will start. Okay, so now we'll start today's session. So basically, today is our fifth number of class, and mainly today I'll try to discuss about that air quality monitoring. So different types of parameter, such as particulate matter PM2.5, then carbon monoxide, then sulfur dioxide, or nitrogen dioxide or methane. So these type of gases, how we can easily trace using the remote sensing technique, as well as how we can easily calculate the total emission of particular gases, as well as how we can easily make the time series chart for temporal analysis. So these type of things I will also try to explain, as well as I also try to explain about that our ArcMap software, basically ArcGIS software, how we can easily use and create the different types of map. Okay, so basically I hope after completing the today's session, you can easily download any kinds of TPMS from the Google Earth Engine platform, and then you can easily make the map using the ArcGIS, mainly ArcMap software. Okay, so now let's start our today's session. I simply share my screen, and completing the today's session, then we talk about that problem solving class. Okay, so let me share my screen. Can you see my screen now? Okay, so is it visible?
Yes, sir.
Okay, thank you. Okay, so, okay, so basically, yeah, so these are fifth day syllabus. Today I'll talk about that air quality monitoring, how we can do different types of parameter. I will explain all of parameter one by one. I hope you can easily get the idea how we can easily use the Google Earth Engine to monitor the different types of air quality parameters. As well as we talk about that how to download the time series data in CSV file format. Okay. In Google Earth Engine platform, we can easily get the time series chart, and from the time series chart, we can easily download the CSV file. Sometime when you want to work with the big region, suppose your study area is more big, then this time series chart cannot be created. Suppose it has the limitation of Google Earth Engine. When it across the limit of 5,000 element, then this time series chart cannot be created. For that, we also need to know about that how we can easily directly download the CSV file. Okay, any kind of data set, it can be air quality parameter data or NDVI time series data or any kinds of time series data. When you want to make the time series chart for the big study area, then sometime you face this type of problem. It showed that there's a lot of pixel values, so that's why this chart cannot be created. So this type of problem you can face. So that's why when you want to work with the big region and when you face this type of problem for creation of chart, then we directly download the CSV file. Okay, in Google Earth Engine platform, we can directly download the CSV data, time series data in CSV file. Further, we can easily make the time series chart using the Excel. Okay, as well as we talk about that air quality monitoring time series chart and how to calculate the total emission of any gases. Suppose how much nitrogen dioxide gas is emitted in a particular time period for any specific region. So these type of things we try to discuss about that. As well as we also talk about the Sentinel-5 satellite imagery, as well as AOD, mainly aerosol optical depth. We also talk about that, how we can easily monitor the AOD, and also PM2.5, how we can get the from the AOD dataset, how we can convert into the PM2.5, as well as we talk about the ArcMap software. So basically, how we can easily create after downloading the TP images from the Google Earth Engine platform, how we can easily create the map using the ArcMap, mainly ArcGIS software, how we can easily create the proper map. So these things I also try to explain one by one. So let's start. So here you can see it's see the two map in here. Here one map is the methane concentration of the Kuwait, as well as also map show the nitrogen dioxide concentration year of 2020 month of January in Bangladesh. So here you can see we can generate the two map. One is that methane, another is that nitrogen dioxide. So here also you can see about the legend. Methane is show the ppb unit, and nitrogen dioxide is the mole per meter square. We can easily convert the different types of unit and get the take the result. So this type of map, how I can create it. So first of all, we need to extract the data from TIFF format, mainly GeoTIFF format, from the Google Earth Engine. We download the data, and further we are just use here the ArcMap software, mainly ArcMap software. Then we can easily create this type of map. Okay, for our research paper or presentation, for our visualization data. Okay, so today's session I also try show you that process, how we can easily create this type of map after downloading the TP images. Also you can see this is another nitrogen dioxide level rebound in Bangladesh for the different time period, before lockdown, during lockdown, post lockdown, as well as we also make the classes. You can see about the very low, medium, high, very high. So this type of classification we can also do in ArcGIS software. After downloading the TP images, we are just make the classification for the using the thresholding value, low, very low, medium, high. So these type of things we can also do in ArcGIS after downloading the GeoTIFF file format for the different time period of the data. Okay, so basically in this time, first of all, I try to explain about that Sentinel-5 satellite imagery. Okay, so basically Sentinel-5 satellite imagery is focused on air quality and composition of climate interaction with the main data product, mainly ozone, nitrogen dioxide, sulfur dioxide, formaldehyde, aerosol, carbon monoxide, methane. So all of gases, this type of gases, we can easily access from this Sentinel-5 satellite imagery, and we can easily make the concentration map. We can easily make the time series chart, as well as we can also make the different types of analysis using this data set. Okay, so this is the link about this data set. You can simply go to this link, then you can easily get all of data. Or if you want, you can simply open your code editor. Suppose I simply open the code editor, go to this link, and then open the code editor. From the code editor, you can also access all of data set. So just you can see the search place and data. Click on here. You can see the browse data catalog. Click on here. And further Sentinel. And here you can see the Sentinel-5 tropospheric monitoring instrument. And here you can see this data set, mainly it focuses the concentration of the ozone, then methane, then formaldehyde, aerosol, carbon monoxide, nitrogen dioxide, sulfur dioxide. So all of gases we can easily access from here, and this data set is the globally available. We can easily create for any region when you want to use the data. Okay, so in this time, suppose I want to work for the specific data, which is suppose okay, nitrogen dioxide. Okay, so just click on the nitrogen dioxide, and here we can get the data set availability time period. We can access the data set from year of 2018 to 2024, this time period. And this data set provider is that European Union, yes, Copernicus. And this is the Earth Engine snippet. So basically, this is the unique ID. All of image collection have a unique ID. So that's why you can easily use this unique ID, and we can easily work with that. Okay. And also you can see about the resolution about this data set, 1113.2 meter pixel area, as well as also you can see the description or image properties. We can get the bands. So here you can see we can get the different types of band for the different phase of you can see Nitrogen first band is the nitrogen column number density. Unit is the mole per meter square. As well as also you can see the tropospheric level density, stratospheric level. Okay. Yeah. Okay. Any question? Okay. Okay. Let's continue. Okay. So here we can get the different types of band in here, and we can easily work with for the different types of data from here. So in this time, I want to work with this data set, and first of all, I want to visualize the concentration map. Suppose I want to make the map of Bangladesh, year of 2024, month of January, for nitrogen oxide concentration map. So what can I do for that? Same process, just simply copy this unique ID of this data set, and then paste here. Okay, and then give a variable name. You can put any name, and before the variable name we have to use the var keyword and put the variable name. Suppose I put the name is that data set. Okay, and in this time you have to select the specific band, which band you want to work. Suppose I want to work for the density. Okay, nitrogen column number density, I want to work with that. I simply copy this band name, and this unit is the mole per meter square, and further paste here. Okay, and then you can simply put your specific time period. You can simply put this time period. Suppose I just put here that dot filter date and choose your time period. Suppose year of 2024, 1st January from year of 2024. Suppose January 31. Okay, I want to make the concentration map year of 2024, month of January. Okay, and then if you want to check about the image collection, suppose how many images is available for that, simply print and call the data set, and now put here the size function. So now it computing how many images are available only for the month of January, year of 2024. Here we find out the total 417 images. Okay, so this is my image collection. Okay, so now I can use the image collection and I can easily make the time series chart. Suppose I want to check the temporal change of the nitrogen dioxide for the different time. Okay, so for that we already know about that how we can easily make the time series chart. UI dot chart dot image dot series and put all of argument one by one. So just I make a curly bracket start and also curly bracket in here. So first of all, image collection, we already create the image collection. Our image collection is that mainly 417 image collection. Okay, so just I simply copy and then paste here. Then region mainly it's your study area. In this time I simply choose the study area. Suppose whole country boundary of Bangladesh. Just I simply import the shape file of whole country boundary of Bangladesh and put the name. Suppose you can put any name as a variable. I put the name suppose RY. Okay, and further I just put the region is that RY. So now reducer, in this time if you want you can monitor the maximum, minimum or average. Suppose I want to show the average, so put here EE dot reducer dot mean. So now it calculated the average time series chart. But when I put here the max, it make the maximum time series chart, maximum time series concentration time series chart. When I put here the mean, it show that minimum time series chart. So in this time mean we put its average. Okay, and put the scale. Scale is your 1113.2 meter scale. X property default we put here that system time start. Okay, so this is our full things in this time. So now these things I just stored it in a variable. I put the chart and then store it in here, and further we are just print that. So print the chart. So now it make the time series chart, average time series chart between this time period of the concentration of the nitrogen dioxide from year of 2024 1st January to 31 full January, month of January. So now it's generating this chart, and it also takes some time because our study area is big. We consider in this time full country boundary of Bangladesh. Okay, but when you want to just for a small city or a small boundary or a small study area, then the chart is very quickly we can get the result. But in this time we imported the full country boundary of Bangladesh, so that's why it takes some time. Sometime when it across the limit, then we face the problem. It shows that the chart cannot be created. There's a lot of pixel value. Okay, so for that we also need to learn how we can easily download the CSV file directly. We download the CSV file without creating the chart. Okay, let's see what happened about that. Okay, I hope okay, so I hope everyone can hear me properly. Okay, you can see it takes some time because it's our big study area, and sometime when it across the limit, then the chart cannot be created. So let's see what happened for the whole country of Bangladesh. Yes, it takes a lot of time. Okay, you can see it takes a lot of time. Okay, so basically it depends on our study area. When you want to work with the big study area, it takes a lot of time, and sometimes it show the result, the chart cannot be created. But when you want to work for the small area or small study area, then it works very well. Okay, so let me check for the small study area. Suppose I consider only for the Dhaka city. Just I simply import the Dhaka city, and I want to put here the Dhaka city name is the AOI. Okay, and further I want to make the chart for my AOI, which is stored at the Dhaka city boundary. So now let's check the result. What happened? Okay, you can very quickly we can get the time series chart. But for the whole country boundary of Bangladesh, it take a lot of time, and sometimes the chart cannot be created because there's a lot of pixel. So for that, we also need to learn how we can easily create the CSV file. So when you want to just make the CSV file, you can download the CSV file, and then you can easily work with that. Okay, so further I also discuss about that how we can easily create the CSV file without creating the chart. You can see from the chart we can also download the CSV file. It's not a problem. But if the chart is not created, then what can I do? Then we are just downloading the CSV file directly. Directly download the CSV file, and then we can easily open and then work with that. Okay, in this time you can see it work. We can easily get this type of chart. In this time the chart has a problem. You can see this problem is that it show the 0. You can see, but it have a value. Okay, but in this time it show the null value. You can see 0. Also you can see the 0. Also you can see the 0. So it show the totally null value about that. So it show the null value. So how I can handle this null value? For handling this null value in this time, we need to convert the unit. Okay, in this time this unit is the mole. It show the mole, and this value is very less. So that's why it show the round figure as a 0. Okay, but when I convert into micromole, then we can get the value. Okay, you can see it show the 0. All of value show the 0 because it very near to the 0. It very close near to the 0. So that's why it show the round figure as a 0. But when I convert into micromole, then we can get the result. Okay, so you can see it show the, in this time we can get the only for the one value 0.001 mole. Also you can see the 0. Also you can see 0. Okay, so it show the all of value as a 0, but it have a value. This value is very close to the 0, so that's why in chart it show as the round figure 0. But when I convert into micromole, then we can get the better result. So let's check how we can easily convert the micromole. So it is a mole. So this mole I want to convert into micromole. So for the mole to micromole, what's the formula? Just I simply search on the Google. Suppose mole to micromole. So here you can see just 1 mole equal to this micromole. Okay. So in this time, multiply the amount of substance value by this value. Okay. So in this time, I simply multiply with this value. Then we can get the result in micromole. And then it also show about the value. Otherwise, it show the 0, this type of 0. Okay. Not only for data set, when you want to work for the other data set, for suppose sulfur dioxide or carbon monoxide, you face this type of problem. But solution is the same. In this time, I just convert into micromole. So let's check how we can convert. Okay. For converting this part, we can download, we can just simply make a function about that. And then we try to make the mole to micromole. Okay. For in this time, we are just creating a function, simple function. Suppose if you want, you can just take a variable name. I put the variable name, suppose micromole equal. We create the function. Okay. And this function, I put the element name, suppose image. And then curly bracket start and curly bracket end. In this time, my argument is that this image show the result in micromole. For doing these things, I just simply use the return function, return this image, multiply with the value 1. Okay, this will simply multiply that. Okay, so you can see this is the function. In this function, what can I do? I take a new variable micromole, then equal sign, function keyword. I put the element name is the image or img, you can put a name. This image I want to return, multiply with this value. And I want to apply it. So just put here copy properties. Is this image and put here system time start from system time end. Okay, so this is the function. This function mainly convert mole to micromole, because here you can see when I just multiply this value, then I can get the result in micromole. Okay, so this value I simply multiply in my code, and I want to use the function, and this is my function which I created. Okay, just I simply connect with my data set. So I simply copy the data set and paste here, and then put here the map function and put the parenthesis and also close this parenthesis. Okay, so now this data set is connecting with my function which I created. So now this micromole, I simply copy the micromole, and I want to print this. Simply, this is my data set, I simply print in here. So now let's check what happened. Okay, so in this time here you can see we can get the value, and this unit will be micromole because I multiply with this number. Here you can see we can get the result. In January 2, we find out the result 339.123 micromole. Also, you can see the result. You can see 3rd January, you can find out the 131.455 mole. Also, you can see all value we can consider in this time. All value show the result because I convert into micromole. As well as in this time, you can see I write the function this way. I take the new variable and create this function. If you want, you can just put the same variable. Suppose this variable, I simply connect this function in here. For that, suppose I simply, okay, just I simply commenting this line, and I want to create the function in here. Okay, suppose I just put the function keyword and put the element name image, and then further I put here my argument. My argument is that this image return this image multiply with this value. Okay. Okay. And further we are just put here the copy properties. So put here the dot copy is this image and apply from system time start, and also put here the system time end. Just put here the system time end. In this time, this is my function, okay, and this is my collection. So I want to connecting. So for that, we are just use a function. This function called the map function. So just put here that dot map parenthesis start, and also put the close parenthesis put in here. So now this variable, same variable, you can see in this time, this same variable we are just use, and this variable also added the function which convert mole to micromole. Okay. So if you want, you can use this same variable, or if you want, you can take the new variable and then connect this your image collection with this function, then it also will work. So which one is better for you, can simply follow that. So in this time, we are just use the same variable. Okay, you can see data set. This is my variable, same variable. I stored my image collection, 417 image collection, as well as I also create this function which convert mole to micromole, and I connecting using the map function. Okay, same variable. It is the same variable. Or if you want, you can simply take the other variable, look like that. I take the other variable micromole and I create this function. Further, I simply call this data set because it's my collection and connect with my function which I created using the map function. Now we can get the result look like that. Yes, so further you can simply click on here. We can easily get all of values. Okay. First time it show the 0 because this unit is the mole, and mole this value is very less. So that's why when I convert into micromole, then we can get the result. You can also download the CSV file from here also. But this problem is that when I want to work for the big study area, suppose when I need the result for whole country boundary of Bangladesh, then it will be not work. So for that, we have also need to learn how we can easily download the CSV file directly. Okay. So for that, first of all, I try to show you the about the visualization. So it's our in this time we talk about the visualization. Suppose I have to show the concentration map. Then we talk about that how we can easily create the time series CSV file. Okay. Okay. So in this time, when you want to make the concentration map, first of all, I need to reduce this image collection. Okay. So this my image collection data set. Okay. This image collection I want to reduce. In this time, I want to apply the mean reducer. Suppose I want to calculate the average concentration map. I want to create the average density map of nitrogen dioxide month of January, year of 2024. So for that, I need to create the average concentration map. So let's go try to create. Take a variable. Suppose mean NO2. I call my image collection, which is data set, because in this time we already make the image collection and already convert into micromole unit. Okay, so just I put the data set variable in here, and then I reduce it because I want to visualize, and I want to reduce using the average function. Mainly, I want to calculate the average density map. So just put here EE dot reducer dot mean. And further, I just clip with my study area. Suppose I want to clip with the study area of Bangladesh. So RY. Okay. And now I want to visualize this result. So just use here map dot add layer. I call the mean NO2. Okay. And also focus the center of this boundary shape file. So map dot center object. Object is that RY. Put here the zoom level 10 and click the run. In this time so we can get this type of visualization because I don't add any color plated. So in this time when we add the color, then we also get the more better visualization. For adding the color, I want to choose their own color plated from here. Here you can see they are already provide some color plated. Just I simply copy their color code and then paste in my code editor. Simply paste here. Okay. And further in this time, this value will be changed because in this time I want to convert into micromole. So for that, I simply click on here. And then I just stressing, suppose for that 80% stressing. It show me the result micromole. Okay, just I simply copy minimum, suppose 50 to this micromole, and maximum, suppose this micromole. I simply copy and put in here. Okay, and this is the color. Suppose black show about that low concentration, and red shows a very high concentration. Okay, so now let's check the visualization about that. And not only for that, after doing these things, we have to copy the variable name and paste after the object name. Okay, so this variable stored the visualization parameter I want to add with this layer. So just paste after the object name and also put the layer name. Suppose I put the layer name is the NO2. You can put any name as the layer name. So now it will be connecting with our layer and we can get the result. There you can see we can get this type of concentration map. And this result, this scenario only for that month of January, okay, 2024. So from this step we can easily get this. You can see this type of region, mainly hillcrest region, we find out that low concentration, not mass. Also you can see the mangrove forest. Also you can see the high concentration in the Dhaka city about this region. Okay, it shows the high concentration of the density of nitrogen dioxide. We can also get some. Also you can see this region also for the port. Also you can see this region. Okay, also this region. Okay, so you can see overall scenario of Bangladesh for nitrogen dioxide concentration map year of 2024 month of January. We find out that this region is the highly density. There's a lot of region behind for this high concentration of nitrogen dioxide, as well as also you can see this region. So this is the map for our concentration map or density map of nitrogen dioxide map for the whole country boundary of Bangladesh year of 2024 month of January. We can get this type of result. Further, we can easily export this map as a TIFF format and work with the ArcMap software to visualize this result. So I'll show you the later how we can easily do that. So in this time, we talk about that how we can easily download the CSV file. Okay, suppose download the CSV file. Okay, before that, anyone any question about this full code, you can ask me. Anyone any question or any confusion?
Sir, that copy properties, system start system, and can you please, what are you doing by applying that command, sir?
Okay, so basically in this time here you can see when you in this time element, in this time how much element I take. In this time I took only for the one element. Okay, one element means that one image. Okay, so one image I multiply with this value, but other image mainly other 416 images, what happened? So for other image, considering in this time, we have to copy these properties. Okay, after multiply these properties, I copy and then apply it this image from this time period, start time and end time. So system time start means that this system, this full code, I just put a start time and also put the end time. Okay, so system time start means that this my start time meaning, and also end time means that this my end time on my code. Okay, copy these properties and apply all of images between this time period. And between this time period, how much image I got? Between this time period, I can got total 417 images. So it consider all of images. When I put at the system time start and system time end, it consider all of images and apply this multiplication, all of images. Okay. So system time means that start time and end time, which I put in here.
Thank you, sir.
Okay, thank you.
One question.
Yeah, please.
Just like you did it, from multiple dates. Okay. If I want to do it, like like different locations. Okay, in the same code, how can I do it? Like you did for Dhaka. Okay. For Bangladesh. So if I have multiple sites, the same thing. I think I asked the similar type of question before. How can I select number of dates? Like if you are using the filter date, can I make it like a dictionary and select multiple dates and make a different map?
Okay, so in this time, this code, suppose in this time I consider this time, I just work for that month of January. So I select this time.
Yeah.
So you can put any time period, any time period.
No. My question is, like I want to make all the maps all together in one code. Okay. What I want to do is I want to select different time. Okay. Let's say January of this. This is January. So January of 2023. And I want all of them together. And I need this for different locations.
You have to, okay, so for the same time, you have to use the same location. Okay,
Yeah.
suppose in this time, I want to show the map for January, then February, then March, same location.
Okay.
Okay, then you can use take the data set again and again, and then try to add layer one by one. You have to add the layer.
Okay, so can't I make a multiple map like in the same code, like in the same graph?
Yes, for that we have to create another data set. Suppose you can simply suppose this data set is only for that January. Okay, January.
Okay.
And further you can simply copy the same code, and then make the another data set. Suppose February.
Okay.
February, and then put here the time period. Suppose here of 2020 February, 1st February from February, suppose 28. Okay, and further when you want to make this in this time, what you can do, just simply copy the same code. Suppose this code, simply copy and take the another reducer. Suppose I put here the mean NO2 for February. Okay. And further just call your dataset, which dataset you create for February. Simply copy and then paste here. Then create this average and click with the study area. And further when to visualize, just use the same code. Simply copy. In this time it create the another layer. Paste here and then simply copy this February and then paste here. And also put the layer name, suppose NO2 February. So now let's check. In this time, it
Sir,
create
29, sir.
Yeah.
Sir, you are 29 days, sir.
Yeah. Which one?
29 to 2024, sir. 29. The date, sir. Date, filter date. 29 to 2024, sir. Leap year, na, sir. January has 29 days, na, sir.
Okay. Okay, just a minute. It's not a problem. Let me check. So in this time, we also put here the data set January. So that's why it show the data set is not defined. Okay, so for that we also need to change also in here for our for this. Yeah, so just put in here. And further, yeah. So now it will run again.
No, above also. Yeah. 32 also.
Yeah. It also put here. Yeah. So now we can get the two layer. One is show for that data for January, another layer show for that February concentration.
For the this graph, what to do?
Okay, for the graph, we have to create the monthly image collection. Okay, suppose in this time, we just only for the monthly image collection. So this part I it not completed because you can see this for the previous time. I cannot time to complete this part. Monthly image collection I can create. Okay. So when I talk again about that, because this part is not completed yet, then you can easily get the idea. Any data set, not only for that air quality parameter. When you want to, you can easily get it. So I also try to explain further. Then you can easily get the idea how we can easily any data set for monthly January, February times the chart, how we can create it also work, no problem.
Okay. Just one question I want to add here. If you can go to the code. Now the thing is, right now we have like same shape file. Okay. So we can add as many as months we want. Now let us suppose we have multiple locations, say a country, like in Dhaka you have multiple cities. Can I make all the maps like together, just like changing? I can import the different shape files. Okay.
Yeah.
But can I make the maps, like let us suppose I'm not, right now I have one shape file that I did. I added. Okay, then I can do and make a map. But now I have multiple shape files. Okay. Because let us suppose I have to add some shape files. How can I, decrease the code length? Because if you see, we have to make this thing for every month. Can't we filter it using a dictionary or something like that? Write or at once and everything is calculated at once.
Okay, so in this time, suppose in this time in Bangladesh, here you can see in this time it is stored total 64 district. Okay, the shape file is there the total 64 district boundary is the available. So in this time, suppose you want to show the result only for the specific boundary of district. You can see the total 64 district in Bangladesh. Okay. So in this time, you want to show only for the specific district. Suppose only Dhaka city or Gazipur or other district, you want to visualize this result. So for that, you also need to filter this shape file. Okay. This shape file, you also need to filter region wise. Suppose you make the
I got that point. But the thing is, when I have a large map, okay, I can't do that because then the processing time is too large, like one with Bangladesh, the other time. What I want is have a one shape file and do all the things together. Like I don't want to filter date, make a separate January map, but I want to clip dates differently. You got my point?
Okay, so I come confusion about your question. What do you say?
Okay. Can I make a multiple dates? You you have chose like you have chosen like from 1 January to 31. Okay. But can I choose multiple dates like say 1 to 10 in the same code and then make a combined map?
Okay, it also possible. It also possible. Suppose in this time, if you want, you can simply put the January, then take the February, then March, every month. Okay, and then make the composite and create this map. It is possible. Suppose.
No. My question is, I think I just want to reach. Like you have said from 1 January 2024 to 31 January 2024, it is going to make average map out of it. Okay, I got that. Now, what I want to do is I want to make an average map of weekends. So let us suppose on the day first date, 7 days, 14 days, 25 days, like that. Not a range, just specific dates.
Okay, so you put the only for the dates. Suppose 10 days. 20 days.
Yes, like that.
Okay.
Is it possible?
It's also possible. Yeah, possible. For that, we have to use another function. This function called that. Suppose I show you that. You can see. Suppose advance how much days. Suppose I want to create a filter. Suppose I just take a filter. Suppose I create a date. Suppose ee dot date, and I put the time. Suppose in here I put the time. Year of 2020. Suppose 1st January. Okay, so this is my time. This is my start time. Further, I want to create only for that. Suppose advance 10 days or 20 days or 30 days or 40 days. But it starts from here. Okay, so it also possible. Suppose I take the another per date. or just filter. I put the take a variable. Check. Let me check just a minute. Okay. In this time, suppose you want to take the date, and from this date you want to advance, suppose 1 week, 2 week, or 2 days, or 3 month, anything you can put in here. For doing these things, we just take a variable, suppose, or if you want, you can simply suppose take a variable. I put the variable, suppose final, and then I call this date. From this date, I want to put here advance, and now I put here that delta unit. Suppose I put here the delta. Suppose it's a number. Suppose I take suppose 10 days. So put the unit is that day. Okay, and remove that. It not need. Okay. Suppose you need that 3 week about this data set. Suppose 3, and then put here the week. Week, or suppose 1 year, so just put here, or 2 years, suppose 1, and then put here the year. Okay, in this time, first of all, you need to define a base time. Suppose this is my base, it's my base, and I want to advance 10 days, 20 days, 7 days, 8 days, or 1 year, advance 1 year, advance 2 year, advance 3 year. Okay, suppose let's check, I put an example. Suppose I simply copy that, and I want to put here. Okay, just I write the code before that. I want to make this my start date. Suppose E24. Suppose it will be start this is my base. Okay, and I want to need the data. Suppose for 20 day. Okay, so put here the 20 day. Further, I simply copy the final, and then I simply remove this time. It not need. I already defined this time in here. Just paste here. So now let's check what happened. Okay, now it's about that. Okay, feature collection, null feature, system time start. Let me check. It not work. Okay, so this my start. Oh, sorry, it's my start time. Just I put in here, and this is my in time. In time mainly you can see this is our start. It's our base time. Okay, and then up to 20 days. So it's my in time. Okay, so now try to check. Now it will work, you can see. Okay, suppose you need the advance 50 day or advance 35 day. Okay, so now put the 35. It will be start from here and then go to advance 35 day. So now we can get the time series chart about the 35 day, as well as also make the composite about the 35 days and create this map. Okay, so when you want to put suppose any time period, 10 days, advanced 10 days, or in this time, suppose you can also put it at the week. Suppose you need the 2-week data set, 3-week, 4-week, 5-week, or you need the data set for the 2-month, 3-month, just put here only for the put the unit. You can also get the better all of the suppose search here advance. So you can see then we also get the all of things in here. Create a new date, adding the specific units. Okay, and we can get the year, month, week, day, hour, minute, second. We can easily put this type of unit in here, and then we can easily get the result.
Sir, can we put a combination, sir? 1 month, 1 day, 1 week, like that. 1 month, 1 week, 1 day, like that.
Just you solve like most of my problem. Just one question to that more. Now, what you did, you even now you made some advancements. Okay, 1 day, like from 1 day to 2 day. So in the code, I can only specify 2 dates: start date and the final date.
Yeah.
But let us suppose I have multiple dates, but those are not in increment. Those are like 1 day, 5 day, like let's say first day of the month, fifth day of the month, then seventh day of the month, like that. Just an arbitrary question.
So it's single date, only for the single date.
No. I have multiple dates, but there is no predefined gap between them. Means I don't know. It is like equal spacing is there. There is a different spacing between the dates. Okay.
Yeah.
Let us suppose there is a sentinel data, okay, because of cloud cover, I couldn't see some of the images. So now I know there are certain images, but those are not in advanced. Like there is no same gap between 2 dates. How can I get data for those dates?
Okay, so I understand your question. So in this time, suppose you can put the suppose you can make the composite for individual days. Suppose single day. Suppose 1st January, 6th January, 10th January, 19th January, 20th January. So you can take single date, and this single date you want to make the composite and also make the time series chart for that. Yeah.
Yeah.
Oh, okay, understand. Yeah. So it's also possible. So for that we have to, okay, let me show you the example. Suppose so for that we can easily do it in here. Suppose this thing is that in this time we have to use there the normal filter dot filter dot date. So you can put a date in here, start and end date. Suppose year of 2020. Suppose 10. Suppose 1st January for the first. Okay, but it's a multiple date. You have to show about that. And from here, suppose year of 2020. Suppose 1st January from 2nd January. Then put here that or function, and then put here that again. Suppose dot filter date, and put here suppose year of 2020. Suppose January 10. I put here the suppose year of 2020 January 11. Okay, and then put here the or dot filter dot date. Suppose I put here that year of 2020 1st January. That was 19 Suppose 2020, 1st January, suppose 20. Okay, so now let's check what happened. Okay, show that e.filter is not a function. Mhm. We want to create the single date object first. Suppose we create the date, or okay, if you want, suppose I create the one date object. Suppose then put it the another variable. Suppose date, and put here ee dot. I put the another date. Suppose year of 2024 January. Suppose 10. Date 1. Further take another variable. Date 2. E dot date year of 2024 January 15. Suppose date 3. Suppose 2024 25. Okay, suppose this is my specific date, and I want to create the composite from here. So date 1, date 2, and date 3. Okay. We just make a list all of date. You can get the total 4 date. Okay. So now if I just try to put this final date, it's showing that date range cannot interpret as a date. Suppose this is my start date. And this is my end date. And further, time zone not net. Now date range. Now try to check what happened.
If you want, you can skip it and tell me later. You can proceed with your
Okay, just a
program.
minute. Okay. Okay, so I find out the solution further. I think it also complex for that individual date we selected, and further we try to make the composite about
Yeah,
that.
just if possible, if possible, automatically. Let us suppose we have Landsat images, okay,
Yeah.
and we got the images with dates, having a cloud cover less than 2%, okay.
Yeah.
Just automatically, not writing those dates. If I can automatically, import those like those dates which are we got output from the system, that okay, these are the files having cloud cover less than 2%, we can put them here. You
Yeah,
got my
yes.
point?
Yes.
If possible, please. Thank you.
Okay, so further continue about that. Okay, so let's go. We try to discuss later about that.
Sir, I have another question.
Yeah,
If you have
please.
time, we can discuss now. Otherwise, you can discuss with us later. If we have points data, for example, we have 3 points, and we want to make a buffer of 5 kilometers around these points, and then we want this data. Is it possible?
Yeah, it's also possible. Suppose you can just simply take the point. Suppose this is the point,
Okay.
and this point you want to create the buffer for 5 meter area, and then you can easily extract the data from here. Suppose for buffering, just take a variable. Suppose ROI, or I put here the suppose point equal. Just put here all the geometry, because it stored your point, and put here that buffer. Suppose just put here 1000 meter. So now it create the 1000 meter buffer. So just put here the map.add layer and call the point. So now you can see it create the another layer which is show the 1000 meter buffer area.
Thank you so much. And if I have 100 points in my CSV file, and I will import that file, is it possible? I can.
Yeah, it also possible. Suppose you can simply click on the asset tab. You can see now it create these things. Simply click on the asset tab, and further just click on the new and go to the CSV file. Okay, in this CSV file, simply select your source file, and further here you can get one option. Mainly this option we have to put in here. you can put here your column name. Suppose we can in CSV file have a 2 column must need longitude and latitude. So you can simply put the same name in here and then upload it. Okay, then it will be easily uploaded, and we can easily show this result as a point feature on this map. And further, you can simply put here the buffer, then it will be show the buffer region, and further you can also work with that.
Thank you so much, sir. Thank you.
Okay. So further, okay, so we continue our class just a minute. Okay, I run the code again. So okay, just I put it the normal date, year of 2024, 1st January from year of 2024, January 31. Okay, now try to run the code again. Okay, we can get the 2 map because we can add the 2 data set for January and February. Okay, so now in this time we talk about that how we can easily download the CSV file in Google Earth Engine platform. So for downloading the CSV file, first of all we have to create a function. Basically this function including the 2 column. One column show the date, another column show for the value. Okay, one column show for the date, another column show for the value. So for this thing, just take a variable. Suppose I put the variable name is that CSV equal sign, then put here the function keyword. And further, I want to do using this image. So basically, we just take the image. Okay. So when you want to create any function, we can in this function we can do all of those things regarding this element. Okay. So now I want to use this element, and further I want to calculate. I want to make the dictionary. I want to make the CSV. All of those things. Then I just simply connect this function with my data set. Okay, so you already create the data set. You can see this is our data set. Okay, this is our data set which contains total 2024 1st January to 31 January. All of image collection is stored in this variable in this data set. Okay, this variable. So now when you create this function, look like that. In this function, first of all, I need to create a I need to calculate the value. Okay, so for that I take a variable. Suppose stat equal, I want to calculate the value from this image, from my element. So we already know about that, how we can easily calculate the value for a specific region. So further we have to use here the reduce region. Okay, and put all of argument 1 by 1. So just curly bracket start. And also curly bracket in here. So in this time, first of all, you can see reducer. So basically this reducer is I have to calculate, extract the information for EE dot reducer, suppose average result. So put here the mean. And geometry, in this time you define your boundary shape file. In this time I want to work for that whole country boundary of Bangladesh, which is stored in the ROI. Okay, just put here the ROI. ROI. Then scale is the resolution. Put here the 1113.2 meter. Okay, and further ignore it, remove that.
Sir, CRS means that coordinate reference system. Sir, you can put UTM projection.
Yeah. So coordinate reference system is the automatically defined in here. Okay.
Okay.
But when you download any data set, suppose you want to download some Maxar satellite image or export satellite image. So further, when you want to calculate this type of thing, then we have to define. So in this time we are using the Google Earth Engine dataset. So that's why coordinate reference system is already defined in here.
Okay, sir.
Okay. So now in this time you can see we calculate this only for the value, and this value is stored in this variable stat. And further we have to create the another variable. This variable is stored the time. So just take a variable, suppose time, and then or just put here the date. And this date come from this image. Okay, suppose image acquisition time. Okay, so just I simply call the image, and from this image I want to extract the date. So just put here the date function, and date is a number. This number I want to convert into string. So for that use here the format function. Format is converting number into this into string. Okay, so you can see for my CSV required 2 column I created. One column is that stat, another column is the date. Okay, stat mainly calculation. Suppose I want to extract the average result of each date. Okay, so just put at the mean. You want to calculate the maximum, so put at the max, minimum, put at the mean, then you can easily get the result. And we also extract the image. For image date, we extract from here, and it is a number. So further, we have to use here the format function.